For decades, standardized testing operated on a core assumption. An IQ score measured a fixed, innate biological capacity. But historical data presents a massive mathematical problem for this idea. If we apply modern testing standards to average individuals living in the early 1900s, their resulting scores would classify them as intellectually disabled. Evaluation from the opposite direction reveals an equally jarring result. Evaluated by the normative standards of 1910, a modern average person would register as a profound, unfathomable genius to their ancestors. Human genetics and evolutionary biology do not mutate this rapidly. Our DNA is virtually identical to a factory worker from a century ago. So what caused our brains to shift this significantly? This secular rise in cognitive test scores, documented systematically over the 20th century, is known as the Flynn effect. It challenged the notion that population intelligence is a rigid biological constant. The scope of this cognitive boom was brought to light by political scientist James Flynn. In 1984, he analyzed every major American psychometric testing norm from a 46-year window. Flynn utilized a rigorous method called norm obsolescence. By tracking subjects who were administered identically scored yet differently aged test batteries, he could isolate the temporal variable. Because the subject's baseline ability remained constant across the two testing sessions, any difference in score proved that the older normative standard was inherently easier. This graph plots IQ standardization norms from 1932 to 1978. Every single representative standardization sample established a higher baseline cognitive norm. Looking at the y-axis, we see a precise, unbroken mean gain of 13.8 points, progressing at exactly 3 points per decade. In under half a century, Americans experienced almost a full standard deviation of cognitive growth. The immediate question was whether this was an isolated American anomaly or a byproduct of global modernization. In a 1987 synthesis of 14 nations, Flynn found the answer in European military conscription records. The Netherlands, for instance, mandated testing for virtually all 18-year-old males, providing a direct population-level comparison. This comparative bar chart illustrates the magnitude of the Dutch data. A generation of sons tested in 1982 outperformed their biological fathers tested in 1952 by roughly 20 IQ points over a single 30-year span. When breaking down the specific domains of intelligence, the gains in crystallized intelligence, like vocabulary and formal schooling facts, were modest. But the explosive, standard deviation-altering growth occurred in fluid intelligence, the capacity for on-the-spot pattern recognition and abstract problem-solving.
While facts and vocabulary remained relatively stable, the rapid growth in fluid reasoning suggests that modern life began to prioritize the mental agility required for abstract, on-the-spot problem-solving. Because biological evolution cannot recode a gene pool in 30 years, the origins of these massive IQ gains must be driven by environmental factors. Researchers point first to the nutrition hypothesis. Over the 20th century, industrialized nations eradicated chronic childhood malnutrition. Better intake of high-quality proteins and micronutrients directly optimized early neurological development and increased average brain size. Then came the global expansion of compulsory schooling. The academic curriculum acted as an intense neurological workout, specifically training the classification and formal logic and hypothetical thinking that fluid intelligence tests measure. Fertility patterns also shifted.
As the century progressed, average family sizes shrank. This concentrated higher levels of parental time, adult-child interaction, and financial resources on fewer offspring. Flynn himself emphasized the demand for scientific spectacles. Modern life forces individuals to constantly manipulate complex software, engage with hypothetical logic, and interpret symbolic media. These factors compounded into a social multiplier effect. A slightly better cognitive environment raised an individual's intelligence, prompting them to seek out and build even more complex environments, creating a compounding feedback loop across generations. These massive, environmentally driven gains present a paradox when weighed against decades of behavioral genetics. Rigorous twin and adoption studies consistently prove that by adulthood, intelligence is up to 80% heritable. If genetic variance determines 80% of the intelligence differences between individuals within a specific cohort, how can environmental factors cause massive 20-point shifts across entire generations? This animated model shows how we resolve the paradox using height as an analogy. Human height is roughly 90% heritable, yet the average height of North and South Koreans, populations with identical genetic backgrounds, differs by several inches, entirely due to massive nutritional differences. Genes set an individual's hierarchical ranking within their own family or society, but the shared environment acts as the absolute tide that lifts or lowers the entire population at once. While the Flynn effect defined the cognitive trajectory of the 20th century, longitudinal psychometric data from the mid-1990s onward reveals a concerning trend.
Across several highly developed nations, intelligence gains have plateaued and are now measurably falling. This chart models Norwegian familial data, proving the decline is environmentally driven. We trace an older brother's IQ peak in 1975 and follow the declining line to his younger biological brother, who scores lower despite sharing the same parents. Researchers point to the ceiling effect hypothesis. The environmental levers that pushed IQ upward, like basic childhood nutrition and universal education, have reached full saturation. The floor is entirely lifted, meaning the rapid, continuous gains had to organically halt. Any subsequent decline stems from modern environments actively eroding abstract reasoning capabilities. The ubiquitous use of smartphones, hyper-fragmented digital media, and artificial intelligence encourages individuals to outsource declarative memory and spatial navigation to external devices.
We are offloading our cognitive burdens. Consequently, nations like Norway, Denmark, Finland, and the UK are seeing fluid intelligence drop, erasing previous decades' gains. The initial discovery of the Flynn effect proved that human intelligence is a highly adaptable muscle, forged by the rigor and complexity of our society. But the reverse Flynn effect serves as a warning. Cognitive gains are not a permanent evolutionary upgrade. If a society stops actively challenging that muscle, it will atrophy. Take a hard look at the cognitive environment you are building for yourself today. Are you exercising your focus or offloading it? To explore more deep dives into the science of human behavior, hit the subscribe button and watch the next video.